We're now going to do a series of problems that review many of the things that we've covered in this first unit of study. So here we have a mass. We can see it starts from rest. We have a force applied to it. It's got a mass of 3 kilograms. And the coefficient of static and kinetic friction is given. And we want to know what's the friction force and what's the acceleration of the mass if this applied force is 2 or 4 or 9 newtons. Let's see what we can do here. If we take G to be 10 meters per second squared, which is a fairly good answer, we can see that the weight of this object is 30 newtons. And since the weight and the normal force are the only two vertical forces, that must mean that the normal force, which acts in the upward direction, is also numerically equal to 30. The maximum static friction force is the coefficient of static friction times the normal force. Well, that turns out to be, what is that? 0.2 times 30. That's 1/5 of 30, 6 newtons. Which means until we pull with 6 newtons over here, this thing isn't going anywhere. Over here, when this applied force is only 2 newtons, we can say right now the acceleration is 0. Here the acceleration is also going to be 0. And the friction force is just going to be exactly 2 newtons, and it's going to be static friction. So what we're saying there is when we pull with a force on the right here, this mass isn't going anywhere until that force reaches a magnitude of at least 6 newtons. And when it's less than 6 newtons, then our friction force is equal to that, because then the sideways forces will cancel. Well, what if we exceed the 6 Newton threshold for friction? Then this mass is going to start sliding. And at that point, kinetic friction comes into play. And kinetic friction is mu sub k times the normal force, and that's going to be 0.1 times 30, which is 3 newtons. So as this mass is sliding, there are 3 newtons that way that are acting due to friction. And if we're applying 9 newtons to the right, look at the picture, and friction is 3 newtons in the reverse direction, I think that means that the force of friction is going to be 3 newtons, first of all, which we're asked to find. And why don't I put F sub k there so we make sure we know, hey, that's kinetic friction now. And the net force will then be 9 minus 3, so that's 6. And according to Newton's second law, the net force is equal to the mass times the acceleration. The mass is 3, so that must mean that for this last case, the acceleration is going to have a magnitude of 2 meters per second squared.